What is a motor unit? It means that one nerve fiber can innervate multiple muscle fibers. And this is good for efficiency, because if you have one nerve fiber for each one muscle fiber, first of all, the thickness of the nerve will be very big, the same size as the muscle. And the second thing, you need a lot more coordination. And sometimes you don't need coordination. A lot of muscle movements are basic, so you don't need a lot of coordination. So once the signal is sent, multiple muscle fibers can contract at the same time. So this is why the whole thing is called motor unit. So one nerve fiber plus multiple muscle fibers that responding to the nerve stimulation. And recruitment is something different. So when you're doing some kind of activity, when you're moving something, when you want to overcome a load or a weight, initially small fibers are activated. Okay, that produces a little bit tension, but if it cannot overcome the load or the weight, then you have more fibers are involved. If it can overcome, that's good. If it cannot overcome, then the bigger fibers are involved. Finally, it may overcome the load, but this produces a lot of tension. And as you can see, the time, it gradually increases. All of them will not happen at the same time. It gradually increases. And that gradual is important for a smoothness of the motor activity, and also to preserve extra energy. For every movement, you do not need to activate all muscle fibers. You only activate more muscle fibers if you need it. If you don't need it, you don't need to do it. For example, if there is a crime somewhere, you don't need to call all the cops of the whole county in that area. You don't need it. Only you may need 1 or 2 or 3 cops there. The same idea here. So once then there is a need for it, then you can recruit more muscle fibers. Classification of the muscle contraction. One is called isotonic, and the other one is called isometric. So isotonic means the tone is the same, but the length of the muscle is different. So there's 2 types here. One is called concentric, and the other one is called eccentric. For the isotonic contraction, for example, lifting something or walking and things like that, these are examples of isotonic contraction. So in the concentric one, the amount of tension that is produced in the muscle can overcome the load or the weight, and the length of the muscle decrease. Okay, for example, you can lift something, and this is not heavy, and you can lift something and then you can carry it. The other way around is that the load is really heavy. You cannot lift it. It's very heavy. And in that kind of a case, the muscle can still contract, isotonic, but because of the gravity, the length of the muscle increase, because the amount of tension that is produced in the muscle, it cannot overcome the load. Okay. For example, you want to go to gym and you want to lift something. If you're lifting something small, it's easy, you can do it. But if you're trying to impress your friends and try to lift something heavy, and then you know that nobody will be impressed with your movements in the gym. So even if you try to do it, nothing will happen. So you will have an eccentric contraction. Compared with me, if I go there, I will have concentric contractions, right? I'm joking. So the other one is isometric contraction. So the isometric contraction, the length of the muscle remains the same. So this is important for posture or keeping a specific body positions. So here is that this is important for resistance training. So the amount of the tension that is produced is different, but the length of the muscle remains the same. The load and the speed of contraction, they are inversely related. So If it's a small load or weight, it takes less time for the muscle to contract and increase tension. So once the tension is increased, the length of the muscle decrease, and you can keep the tension for a longer period of time. But if it is a bigger load, it will take longer time to start, and you cannot keep it for a long period of time. So the amount of tension that also produced may be not as much, because the load is so high that even if you try to produce a lot of tension, the muscle cannot contract as much, so that the length of the muscle may not shorten enough. That again depends on the situation and the type of activity, but here we are talking about the timing and the speed of the contraction. So here it will be shorter, and it takes longer time to start. Okay, so there's a few different definitions here about the motor unit and the tension production. One is called maximum tension. So in the maximum tension, all motor units contract at the same time. They reach maximum tension, so the highest tension that is possible. So the problem with this is that you cannot continue having this status, because all the energy that is in the muscle fibers that is used, so it's only working for a very short period of time. The amount of tension will be high, the amount of force will be high, but the duration will be very, very short. Compared with the sustained tension, here you do not use all your muscle fibers. You use some of them, and that will increase tension, but it will not be maximum tension because you didn't use all muscle fibers in the whole muscle. Once those muscle fibers are tired, then the muscle fibers that were relaxing will take over, and those muscles that were tired will get their oxygen, and then they will have their ATP production, and they were ready to take over again. So then you can continue doing this for a much longer period of time. And the muscle tone is that very, very few muscle fibers are active. So this is for body positions. For example, you are sitting and your head is straight, or when you are standing, you are not falling down, because the back muscles and the lower limb muscles are contracting, but not all of them are contracting, because you get tired very fast. So some muscle fibers are contracting, and that keeps your posture and body position. So this is without movement. It's just for a specific body position. What will happen when the muscle is relaxed? When the muscle activity stops, the return of the muscle back to its normal length depends on a few different factors. One is the elastic forces that are there. So you have ligaments and tendons that has some elastic fibers, and that will bring the muscle back. You also have the titin protein inside the myofibrils that is helping there. The other one is the opposite muscles. So for example, you're abducting, and then you have other muscles for adduction. So those muscles will help bring it back to the original position. Or for example, you're flexing and you have the extensor muscles that are opposing those movements. And the last one is the gravity that's always helping. For example, you're lifting your hand or your limb for a while, but you cannot do it forever, and the gravity brings it back to the original position.